In this video, I'm going to help you prepare for the math test by breaking down the 12 most important skills that you need in math to be able to pass this test. And I've added chapters to the video to help you navigate to the appropriate skills. The first one I want to look at is how you can find number patterns. Now, there's always questions about these, and there are some certain tricks that you can use that really help you to solve these questions. So, the way that you do it is to always do these steps first, because if you follow these steps, it will really help you decode it and will often solve the problem. So the first thing you do is you find the first difference. And by that, I mean you subtract each number from the number before and find the difference between two terms that are next to each other. Then what you do is you find the second difference. So by that, I mean the difference between the differences. And I'll show you examples of doing that. Then the next thing you can find is the common ratio. So what you do is you divide one number by the number that comes before it, and then try that for all of them and see if you get the same number. And from that can help you work out if there is a multiplying pattern. A good thing to always check for is square numbers and cube numbers, because they can also be a common basis for some patterns. So by square numbers, I mean things like 1, 4, 9, 16, 25, and so on. So that's like 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. Or you could have cube numbers like 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, and so on. So I'd memorize those sequences, and if you start spotting patterns around those numbers, you know there's something to do with square or cube number. So follow those steps and it will solve the vast majority of sequences, or will really help you understand it and help you head towards the answer. So let's look at some examples of how you can do this in practice. So let's look at this question. So what number comes next in this sequence? So what we'd always do is find the first and second difference and see if that tells us anything and helps us work it out. So to find the difference, you'll do, for example, 5 take away 2, and then you'll write that in the middle. Then 10 take away 5, 17 take away 10, 26 take away 17, and so you'll get each of these numbers. So you can see, obviously, 5 minus 2 is 3, 10 minus 5 is 5, and so on. Then what you need to do is find the second difference. So that's a difference between your differences. So you've got 5 minus 3, which is 2, 7 minus 5, which is 2, 9 minus 7, which is 2. So we're seeing that all the second differences are 2. Once you get the same number over and over and over again, that's telling you that you spotted something important. So obviously there's a pattern here on the second difference. So the next second difference is obviously going to be 2. What we could then do is work out, well, what number must be here on the first difference? Well, obviously that's going to be 9 plus 2, and so that'll give us 11. You can see 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 2 is 11. There's our pattern. So then we can use this to work out the next number. So 26 plus 11, that gives you 37, and 37 is the answer. And we've solved this problem. Let's look at another example. It's a little bit more difficult. So we could have a sequence like this, and this one looks a little bit strange. It looks like it's going up and going down, so it's a bit more complicated. So sometimes you have to consider the sign. Is it changing by plus or changing by minus? So what we can do is find the first difference. So we're doing 112 take away 110 to get plus 2. But then 107 minus 112 is minus 5, and then we have plus 2, and then we have minus 5. So you can see that there seems to be a repeating pattern here. Plus 2, minus 5, plus 2, minus 5. And so there's clearly a pattern there. So you can think, well, what's going to come next? Well, that's going to be plus 2 to keep the pattern going. 104 plus 2 gives you 106, and 106 is indeed the answer. And that basically solved this problem. So by doing the first and second difference, it helps you spot the pattern. If that doesn't work, the next thing you can look at is a common ratio. So that is by dividing. So what you could do is you could do 20 divided by 100, and then 4 divided by 20, and then 0.8 divided by 4. So you're taking the term and dividing it by the term before. And so if I do that, I get 0.2 over and over and over again. And what this tells me is if I do 100 times 0.2, I get 20. If I do 20 times 0.2, I get 4. If I do 4 times 0.2, I get 0.8. This 0.2 is called my common difference. Then what I can do, or rather common ratio to be more specific and more accurate, then what I can do is use this common ratio. So I can do 0.8 times 0.2, and that gives me 0.16, which is the next term in the sequence. And that's how I solve this. So for every one of these questions, start finding the first difference, then the second difference, and then check for a common ratio. And the combination of those three things should allow you to solve the sequence. If not, check for common patterns and then try something a little bit more creative, because it's obviously a very difficult problem. But for the vast majority of questions, this gets you straight to the solution. The next one I want to look at is how you can find the percentage of a number. And this is very, very simple if you follow the right process. So, for example, we could have 12% of 80. Now, what you need to do is find out easy percentages. So, things like 10%, 5%, 1%, these are all very easy to find. So, if we wanted to find 10% of 80, we just divide it by 10. So, 10% of 80 is 8. We could then get 1%. And to get 1%, we could just say, well, 10% is 8. So 1%, we have to divide that by 10. So 1% would be 0.8. We then think, how could you make 12% from 10% and 1%? What you could do is say, well, 10% plus 1% plus another 1%, that adds to 12%. And we know that 10% is 8, and we know that 1% is 0.8. So there's our 10%, which is 8, plus our 1%, which is 0.8, plus another 1%, which is 0.8. Add that all together, and we get 9.6. And there we found 12% of 80 without having to do any challenging maths and definitely not requiring a calculator. But what if the numbers were a little bit more annoying? Say, for example, we had 27% of 76. This will require a little bit more thinking, but because we're sticking to nice numbers like 10% and 1% and 5% and things like that, we don't have to worry about doing really challenging maths. So we could find 10%, and all I need to do is take 76 and divide it by 10, which is obviously 7.6. If I wanted to find 5%, which might be helpful in making this 27, all I need to do is divide 10% by 2. So I just half it. So we get 7.6 halved is 3.8. Then if I wanted 1%, I just take my 10% and divide it by 10. And so if we take 7.6 and divide it by 10, we get 0.76. You could make 27% in various ways. You could do 10% plus 5% plus another 10%. That will give you to 25. And then you'll need 2 more from the 1%. So in other words, we're doing 2 lots of 10%, 5%, and 2 1%. You could work out 20% and work out 2%, and that might make it easier. But let's just do it in the simplest way. So to say 10% plus 10% plus 5% plus 2 1% adds up to 27. So we just replace each of these with the appropriate numbers from this table here. And when we add it all up, we get 20.52, and this has allowed us to find 27% of 76 without having to do any challenging math. So if you use this method, you'll be able to score on these questions. The next one I want to show you is a trick for dealing with compound interest, so like putting money in a bank and getting interest, or if something is depreciating and going down in value, there's a nice trick that can be used to solve these problems quickly and easily. So let's look at the trick in action. So the compound interest trick is to use this formula. So the final value is the starting value times 1 plus the interest rate converted to a decimal to the power of the time. So for example, 1% as a decimal would be 0.01. I've just divided it by 100. 5% would be 0.05, dividing by 100 again. 10%, if we do 10 divided by 100, we get 0.1. And 15%, 15 divided by 100 is 0.15. So that's how I convert it to a percentage. So let's look at this in action. So Mary deposits $100 in a bank at 2% interest. How much will she have after 2 years? Let's look at the formula. So we need to work out the start value, which is $100. The interest rate is 2%. 2% as a decimal is 0.02. That's 2 divided by 100. And then the time is 2 years. So I just substitute that into the formula. So I replace the start value with 100. And then 1 plus 0.02 is 1.02. And then we've got squared. This exam is obviously non-calculator. So what you'll need to do is work it out without a calculator. So we can basically do the calculation in 2 steps. So we would do 100 times 1.02. That deals with the 1 times multiplying by 1.02, but it's squared, so we need to multiply it by that again. So we would then do 102 times 1.02 again. So it's now squared because we've done it twice. and that gives you 100.04. Make sure that you're confident before your test in multiplying by decimals, because that is something that's very, very common, but is really easy to do. And so our final answer is $104.04, and that's the final answer. Let's look at an example where we've got depreciation. So Bob paid $10,000 for his car. It depreciates by 10% a year. So that means it's going down 10%. So that'll be 0.9. What we're having to do this time is we're having to do the start value. Normally we do times 1 plus the interest rate. However, for depreciation, and that means going down each year, we do 1 minus. The minus makes it go down. And so 10% is 0.1. 1 minus 10% is 0.9. And we can see from the question that the time is 2 years. So we can do the substitution here. So we've got 10,000 times 0.9 squared. Just like in the previous question, because you don't have a calculator, you might need to do this in 2 steps. So what you can do is you can multiply 10,000 by 0.9 to get 9,000. Then you take that result, the 9,000, and times it by 0.9. And so you've now done the 0.9 twice. So that's giving you 0.9 squared effectively. And then you get the answer for the final value of $8,100. So you should now be able to deal with questions where you've got depreciation and questions where you've got interest added using this quick and simple trick. The next one that is extremely common is questions around converting a percentage into a fraction. And it's very simple if you know how. So the method that you follow is 3 simple steps. Step 1 is you put the percentage over 100. Step 2 is you find the biggest number that goes into the top and the bottom number. Step 3 is you divide the top and bottom by that number. So I'm going to show you 2 examples of this in action, and you can see how I follow each of these 3 steps. So let's look at a simple example. What is 90% as a fraction? So step 1 says, put the percentage over 100. So the percentage is 90, I put it over 100. 90 over 100, that's done the first step. Then we need to find the biggest number that goes into the top and the bottom. So we're looking at the 90 and we're looking at the 100, and we're trying to work out what is the biggest number that both 90 and 100 divide by. And with a bit of thinking, you can work out that it is 10. So I divide the 90 by 10, and then I take the 100 and divide that by 10. So obviously 90 divided by 10 is 9, and 100 divided by 10 is obviously 10. So 90% as a decimal is 9 over 10. This is a very simple example, and you probably could have worked that out just by looking at it. However, you could have a little bit more annoying. For example, 72% as a fraction. This is much closer to what you would get on the test. So let's look at how you do this. And in fact, it's exactly the same thing, just with a little bit more thinking. So we take the percentage, 72, and then we put it over 100. There, we've started it. Then you have to think really hard, go through lots of different numbers and find what is the biggest number that 72 divides by without leaving a decimal, and 100 divides by without leaving a decimal. And after a bit of thinking and checking, you can work out that it is 4, because 72 goes into 4 and 100 goes into 4. So do 72 divided by 4 and 100 divided by 4, and then we get 18 over 25. And that is 72% as a fraction. Nice and simple. The next one I want to look at is related again to fractions. You have to be able to multiply fractions and do it confidently. The good news is multiplying fractions is very, very simple. So let's look at an example. So if you've got a half times a half, you really don't have to do very much thinking. When you multiply fractions, all you do is you do the top times the top, and then the bottom times the bottom. So we do 1 times 1, that's the top times the top, and then 2 times 2 is the bottom times the bottom. So we've got obviously 1 times 1 is 1, 2 times 2 is 4, and so we get a quarter. That is done. And you should be looking at fractions questions and thinking, does that make sense? So if you have, for example, half a cake and you cut it in half, how much of a cake do you have? Well, obviously you have a quarter. So do a common sense check to make sure that you've not done something silly. And that'll help you basically check that your answers are right. Let's look at another example that's a little bit more thinking. So we've got 1/6 times 3 over 8. Exactly the same thing. We just do top times top, divided by bottom times bottom. 1 times 3 is, of course, 3, and then 6 times 8. That gives us 48. However, 3 over 48, we have to think, is that the simplest that it could possibly be? And the answer is no. Just like when we simplified the percentage, we need to look at this and think, what is the biggest number that top and bottom divide by? And it's obviously going to be 3. So we can divide the top by 3, divide by the bottom by 3, and we get 1 over 16 as our simplest form. And that's how you go about multiplying fractions. The next one I want to look at is dividing fractions. And the good news is, if you're good at multiplying fractions, this is actually extremely simple. So let's look at an example. So we're going to do 1/6 divided by 3 over 8. And the way that you start it is to do this. So if you looked at it for a second, you can probably spot the things that I've done. One simple way to remember what's going on here is to call it the KFC method. So K for keep. So this 1 over 6, I keep the same. Then we've got F, which stands for flip. So the 3 over 8 got flipped upside down and became 8 over 3. And then in KFC, we've got a C at the end. So the C stands for change. This divide changed to a multiply. So you can call this the KFC method as a way to remember it. Now we don't have to worry about dividing anymore. We can just worry about multiplying, which is what we just did. So you're just multiplying top times top and bottom times bottom. So we're just doing 1 times 8, which is obviously 8, and then 6 times 3, and so we get 8 over 18. This isn't the simplest form possible, so we have to think like we did with the percentages. What can the top and the bottom be divided by without leaving a decimal or a remainder? And we think, well, 8 divided by 2 and 18 divided by 2, that works. So we get 4 over 9 as our final answer. So for division, you just have to remember the KFC method. The next one I want to look at is how you can add and subtract fractions. And by now you should realize that it is very important to be good at fractions. There's lots of questions that will either ask directly about these sort of fractions things or involve fractions, and you've got to be confident in doing these calculations without using a calculator. So let's look at some traps and some mistakes that people make that if you make, you will just get it wrong, and they're very tempting, and if you're not paying attention, you can do these things, so don't do these things. So, for example, looking at a half plus a half and thinking, well, if I do 1 plus 1 and then 2 plus 2, I'd get 2 on the top and 4 on the bottom. That does not work. Remember, 2 quarters is the same as a half. So you're basically saying if you had half a cake and you added another half cake to it, you would still have half of a cake. 2 quarters is a half. That is ridiculous. You can't just add them together. That will not work. The other thing that people mess up is that they just add top and bottom the same way, and they don't pay attention to the denominator. The denominator is the bottom of a fraction. If you do not have the same number on the bottom of both fractions, you cannot add them. The only way to add fractions, or in fact subtract fractions, is to make sure you've got the same number on the bottom. So on the bottom here we have a 2, on the bottom here we have a 3. And unless you do something about it, you cannot add them. You can never add fractions that don't have the same number on the bottom. So that's important. So what you also have to remember, and that's what was one of the things that got wrong in the previous examples, is that when you add them together, you leave the bottom alone. So we've got a half plus a half. Now these are nice and simple because we've got a 2 on the bottom here and a 2 on the bottom here. Because we have the same thing on the bottom, we are allowed to add them together. But you have to leave the bottom number alone. You don't add the 2 and the 2 together. You leave them alone. So what you get is the 1 add 1 becomes 2, and you just leave the bottom alone, and it becomes 2 over 2. Well, if you do 2 and divide it by 2, well, that's obviously going to be 1. So the answer is 1. And you always do a common sense check to think, I've done this calculation, does this make sense? And if it doesn't make sense, it's probably wrong. So if you look at it, you've got half a cake, and you add another half cake, so it's like putting 2 halves of a cake together, you have 1 cake. Obviously, this is the right answer. The next one you have to worry about is what we call the common denominator. So common means the same, and denominator is the bottom of a fraction. So you've got to have the same number on the bottom of the fraction, otherwise it's not going to work. So we might have an example like the one we did before, but we did it wrong. Let's do it right. So we've got a half plus a third. Immediately you look at the bottom and go, they're not the same. This is not going to work unless I do something about that. So the trick is to do a kind of cross multiplying. So this fraction here is 1 over 2. So I want to look at the next fraction, which has got a 3. I want to times the top of this one by 3, times the bottom of this one by 3. Then for the 1 over 3, I want to look at the bottom of the other fraction, which is a 2. So I'm going to times the top of this one by 2, and then times the bottom of this one by 2 again. So here we've got that. So to go through that quickly again, so I look at the first fraction, and I've got a half, and I look at the second fraction, and on the bottom I've got 3. So I have to multiply the top of this by 3, and the bottom of this by 3. Then I've got a third here. I look at the bottom of the other fraction, and so I have to multiply by that. So I've got times 2 on here, and times 2 here. If you always use this method, it will always work, because 2 times 3 and 3 times 2 are always going to give you the same number on the bottom. So what we would do is just tidy this up. So we've got 1 times 3 is 3, 2 times 3 is 6, so we've got 3 over 6, and then we do 1 times 2, which gives 2, and then 3 times 2, which gives 6. So we've now got the same number on the bottom. So I'm just going to copy this down here so we've got more space to work with. Now we've got the same number on the bottom, so we're now allowed to add things together. So we are leaving the bottom alone, and then doing 3 plus 2, which obviously gives you 5 over 6. This will not simplify any further, so that is now the final answer. And so that's how you add fractions together. Let's look at a quick example of the subtraction. So we look at this one. Again, we've not got common denominator, so we can't just go straight ahead. So we have to use the same idea. So I've got 2 over 5 here, and I've got 4 on the bottom of this fraction. So I do times 4, and then I do times 4. And I've got 1 over 4 here, and I have 5 on the bottom of the other fraction. So I do times 5, and then times 5. So like before, I just tidy this up. So 2 times 4 is 8. 5 times 4 is 20. 1 times 5 is 5. 4 times 5 is 20. And so I've got this. I can copy this down here because I've got the same number on the bottom. I can just do the subtraction. So I'm leaving the bottom alone. So it's going to be on 20 on the bottom. And then 8 minus 5, which is 3. And that's 3 over 20. And that will not simplify further. So that must now be the final answer. And so that's how you add and subtract fractions, nice and simply. The next thing you need to be confident of is evaluating an expression. And by this, I mean you're given an equation and you have to put some values into that equation to find a remaining part of the equation. So for example, we might have an equation that says C is 2b plus 3, and then in brackets, a minus 2. And we need to work out what, for example, C is. So it says if A equals 5 and B equals 2, what is C? So this is simple, put the numbers in and then solve. There are more complicated ones where the equation might need some rearranging and some extra work. So this one's quite nice because it starts with C equals. We'll look at an example that's a little bit more difficult that I've seen on a lot of the practice tests. So for every single question, not just this one, and for everything you do in maths, you must follow the rule of BIDMAS. So that means you do brackets first, then you do indices. Indices are like powers like squared or cubed. Then you do division, then you do multiplication, then you do addition, and then you do subtraction. So you follow it in order. It is a list. You deal with 1 first, then you do 2, then you do 3. If you don't follow this order, you will get the wrong answer very often. If you don't follow this, things will go wrong. You always follow BIDMAS. So to start this question, what you need to do is wherever you see an A, you have to replace the letter A with the number 5. Then whenever you see a B, you have to replace it with the number 2. And so that's what I've done here. So this B, I've replaced it with 2, and I've put brackets around it. When you have a number and then brackets, it means multiply. So this is basically 2 multiplied by 2, because before we had 2 multiplied by B, we now know that B is 2, so we're doing 2 times 2. Then I've replaced the A with 5. Then I have to look at this and say, what do I do first? So I've got to deal with the brackets. So before I do anything else, I need to deal with the brackets. So I'll be doing 5 minus 2, and then I would be getting this. So 5 minus 2 is 3. So I've dealt with the brackets. Then I look through, and I haven't got any powers, haven't got any divisions, so now I'm on to multiplication. So I can do these 2 multiplications. So I do 2 times 2, which is, of course, 4, 3 times 3, which is 9. Now I go through the list, I can now do the addition. And if I follow this order, I'll get the right answer. So I do 4 plus 9, and that gives me 13. And so 13 is the answer. So the key is to put the numbers in and then follow BIDMAS carefully, and you will get the right answer. You can be asked to use the FOIL method. So that helps you multiply out brackets, and we'll look at some examples. FOIL stands for first, outside, inside, last, and we'll look at how you can use this to solve various problems. And to do this, we'll start with some really simple problems and build up to a little bit more complicated ones, which look exactly like the ones you could expect on the test. So here we've got a simple example. So we've got a number and we've got brackets. So we have a 2 and then we've got some brackets with an x plus 3 in it. Now what we need to do is we have to take that 2 and multiply it by everything in the brackets. So what we do is we do 2 times x. Well, if we've got x and we times it by 2, we now have 2 x's. And then what we have to do is 2 multiplied by 3. 2 times 3 is 6, and we got a plus in the middle, so it's plus 6. So what I've done is I've just taken the 2 and multiplied each thing in the bracket by that 2. And so I get 2x plus 6. We could have another example here where we have 2 letters, and we've got a number in front of one of those letters as well in the bracket. Again, we do exactly the same thing. We do 5 multiplied by the x to get 5x. And then we do 5 times 2y. Now 5 times 2 is obviously 10, and so we now have 10y's, and that is the answer. Now let's build up and look at one where you've got 2 brackets. This is where you have to use the FOIL method. So FOIL stands for first, outside, inside, last. So let's do first. So we start at the left and multiply the first terms. X multiplied by x is going to be x squared. Then we go through FOIL and we've got the O, which stands for the outside. So we do the first one times the outside one. So we're doing x times 2, which unsurprisingly is 2x. Then moving through FOIL, we've got I for inside. So we do the inside. We've got 1 times x. So that just means we have 1x. We don't write the 1, we just write x. And then we've got 1 times 2. So this is the L, this is the last one. So we do 1 times 2 and we get 2. We look at this and we go, well, x squared is its own thing. We've got plus 2, which is its own thing. And then when we look in the middle, we've got 2x and we've got another x. So these are what's sometimes called like terms. They're the same sort of term. So we have 2x and we add another x to it. We now have 3x's. So we've got x squared plus 3x plus 2, and that's our answer. So that's how you deal with 2 brackets. You could have another example where you've got 2 letters. And so what you would have to do is do exactly the same thing, but just a little bit more thinking. So we follow FOIL, so we do the first x times x, which is x squared. Then we do the outside, x times y. Now, when we have 2 letters multiplying each other, what we do is we just write them together. So plus xy, that means x times y. So when you see 2 letters together in algebra, it just means multiply. Then we've got to do the inside. So this is the third thing in FOIL. So we do the inside, y times x. Now, you could write yx or you could write xy. It doesn't matter what order you put them in, but just to make it look a little bit nicer, I've decided to put it as xy. It looks like it's yx, but I'm deciding to put it as xy because it doesn't actually matter. They're the same thing. Then what I can do is y multiplied by y, which is going to give me y squared. Now, x squared is all on its own. There's no other x squareds. Y squared is all on its own. There's no other y squareds. But we've got an xy in the middle, and we've got an xy in the middle as well. So these are the same thing. If we have one xy, and we add another xy to it, we have 2 xy's. And so that is how we simplify it, and that's our answer. The next one we're going to look at is where you have 2 brackets and a number. So this is where it gets that little bit more complicated. And this is very similar to questions I've seen on the practice sets for this exam. So what I need to do is think about what I'm doing first. So I'm just going to basically not worry about that 3. I'm just going to worry about multiplying out the 2 brackets, and I'll deal with the 3 later. So I'm just going to stick the 3 on the outside and have a huge bracket where I'm going to put what I get when I multiply those 2 brackets together. So I just follow the FOIL method. So we've got x times x, give me x squared. Then we've got the x times minus 1, which gives me minus x. Again, we don't bother writing the 1. Then I've got the inside terms to do. So 5 times x, which gives me 5x. And then I've got 5 times minus 1 to do, which is minus 5. Obviously, you should spot that if we do minus x plus 5x, you'll get 4x. works. And so I've just combined the two middle terms together. Now I can worry about the 3. And just like the previous examples, when you've got a number outside, you just multiply everything by 3. So I'll do 3 times x squared, then 3 times 4x, and then 3 times minus 5. And so if I multiply everything by 3, that is the answer that I get. So that is how you deal with these sort of questions. The next thing I want to look at is how you solve linear equations. These are the sort of questions like find x, or you're told some of the things in an equation and you have to find something else, but the equation doesn't start with that. So it involves a little bit more thinking and it's a bit more complicated than the previous examples we've looked at. So what you need to do is be able to solve questions where you've got to substitute and then rearrange. So you might have a question that says that c is 2b plus 2, and then in brackets, a minus 1. And the question should say something like, if b equals 5 and c equals 2, what is a? Now, we don't know what the equation is for a. We're given an equation that says c equals, but we don't want that. So what we do is we substitute, and then we're going to have to rearrange it to get a equals eventually. So what we do is we start replacing all of the letters with the numbers. So we've got b is 5, so we've got 2b here, and b is 5, so we replace that. We've then got that c is 2, so we replace the c at the beginning with 2. So this is our substituted expression. We then need to start tidying this up. So what we can do is we can do the multiplications. So 2 times 5 is going to give you 10. Then just like we did with multiplying out the brackets, we do 2 times a, which gives 2a, and then 2 times minus 1, which gives minus 2. Now this equation does not say a equals, so we need to do some more tidying up. So we've got 10 minus 2, which gives you 8. This again does not have a equals, so we need to start basically getting rid of everything that's not a. So we want a all on its own, so anything that's next to it needs to go away. And to do that, we just do the opposite. So you can use the rule, do the opposite. So we've got a plus 8. We think, what's the opposite of plus 8? That's minus 8. So we subtract 8 from both sides. So if we take 8 from both sides, 8 take away 8 is nothing, so the 8 is gone on this side. And then 2 take away 8 is minus 6. Again, we've not got a on its own, we have 2a. We think, what's the opposite of multiplying something by 2? Well, that's going to be dividing by 2. So we divide both sides by 2. We've got minus 3 divided by, minus 6 divided by 2 is minus 3. 2a divided by 2 is just a. This doesn't look very nice, so what I can do is just swap it round. So I've just switched it round, and so I now know that a is minus 3, and that is my final answer. So the key is you substitute carefully, and then you just keep moving things until you've got what you want on its own, and that'll give you the answer. The next thing I want to look at is how you factor a quadratic. So this is what we call factorizing, and there are questions around this. So the basic idea is very simple. We could have a quadratic, and when we say quadratic, we just mean something where the highest power is 2. So this has got an x squared, so that's why we call it a quadratic. And if you want to factorize it, what you've got to do is find two numbers that multiply to give this, and then you need numbers that add to give this. So you look at the number 15, you think, what are all the numbers that multiply to give 15? For example, 3 and 5 multiply to give 15. And then you need those numbers to also add to 8. And if they do, then you've got it. So let's look at 3 worked examples. So don't worry if you don't 100% understand it after the first example. Wait until you've went through 3. You need to see the same thing several times for it to make sense. So the rule is we need 2 numbers that multiply to give the number on the end. So in this case, 2 numbers that multiply to give 15 and add to give 8. And so if we think about that, the 2 numbers that you need to have in mind is 5 and 3. So 5 times 3 multiplies to give 15. 5 plus 3 will give you 8. And what we do is we just start with 2 brackets. So we've got a bracket with x and a bracket with x, because if you do x times x, that's where you get your x squared from. So we now know that we've got 5 and we've got 3. So we've got 2 numbers that if you multiply them together, 5 times 3 gives 15. And if you do 5 plus 3, it adds to give 8. Let's look at this next example. So we have got 21. So we need two numbers. In fact, remember it's minus 21. We need two numbers that multiply to give minus 21. But those numbers also have to add together to give plus 4. Now, 21, when I look at that, I'm seeing 7 and 3. So 7 times 3 is going to give 21. But I need to make sure that it adds to give 4. So what I will need is I'll need a plus 7 and a minus 3. So we've got 7 times minus 3 is minus 21. So the two numbers multiply to give the number on the end. And then if I do 7 plus minus 3, 7 plus minus 3 gives me plus 4. And that's how I do that one. Let's now look at the third example. So I need two numbers that multiply to give plus 24 and add to give minus 10. So as always, you'll notice I always start the question with two brackets with an x in because x times x is going to give me the x squared. I need two numbers that multiply to give 24. So minus 6 and minus 4 will, because two minuses when multiplied make a plus. So minus 6 times minus 4, that'll give me 24. And then if I do minus 6 plus minus 4, so I need to add these two together, then it'll add to give minus 10. And that's how it works. One of the other things that's important to notice is this actually lets you solve the equations. So if you look at each bracket and you make it 0, so something plus 5 is 0, so that would mean x is minus 5. This bracket, I need something plus 3 is 0. So minus 3 plus 3, that gives me 0, so x is minus 3. So I get two solutions, x is minus 5, x is minus 3. So this can actually let you solve equations. Here, x plus 7, if I made that bracket 0, I would use x as minus 7. Here, if I took x as 3, 3 minus 3 gives me 0. Here, something minus 6 is 0, so x is going to be 6. Here, x minus 4, so I need something here that when I take 4 away from it, it'll make 0, so that's going to be 4. So 4 is my other solution. So that's one trick that you can use the factorized form to get to the solution. The next thing I want to show you is how you can solve a quadratic equation using the quadratic formula. And this is one of the most challenging things that you may have to do in the exam. So let's look at a nasty one here. So we've got 2x squared minus 2x minus 4 equals 0. And now to be able to solve a quadratic, you have to have it equal 0. So in the previous ones where I was looking at factorizing, I should have mentioned, you'd have to assume that it equals 0 or know that it equals 0 to be able to solve it. So here, if you don't have something that equals 0, you have to move it to make sure all of the things are on the left-hand side and you've got 0 on the right-hand side. Otherwise, it will not work. Now, the next thing you do is you start naming things. So we're going to use a, b, and c. So whatever number is in front of the x squared, we're going to call a. Whatever number is in front of the x, we're going to call b. So we've got minus 2 in front of the x, so we're going to call that b. And then whatever is left over as your constant term is going to be called c. So in this case, c is minus 4. And then you have this somewhat horrible equation that says that x equals all of that big long expression. I've tried to color code it to make it simple. So what you need to do is every time you see a b, you have to replace it with minus 2, but be very careful about the signs and be very careful about squaring any negatives. Then wherever you see an a, you have to put the number for a. So in this case, you need to put a 2. And whenever you see a c, you have to put the value of c, which in this case is minus 4. So let's do the substitution very carefully. So we need to replace the minus b with minus 2. So I've been very careful to replace the b with exactly minus 2. Then I've got the square root of b squared. So I'm going to replace the b with minus 2, being very careful to make sure I square the minus 2 and not just the 2. And then I'm going to replace the a with the number 2, and I'm going to replace the c with the number minus 4. So I do that substitution, and then on the bottom I've got 2a, so I've got 2 times 2, replacing the a with 2. So that's a substitution. You have to be extremely careful in solving these, otherwise they go wrong very easily. So I need to think very carefully about the next step. So we've got minus 2, so that's going to be plus 2. Minus gives plus. Then we've got minus 2 squared. Minus 2 squared is 4. And then I'm just dealing with 4 times 2 times minus 4. So 4 multiplied by 2 is 8. Multiply that by minus 4, and I get minus 32. I'm being very, very careful with these signs. Then on the bottom, I've got 2 times 2, which gives me 4. Now I need to look at this very carefully. 4 minus minus 32. So minus minus is the same as plus. So it's 4 plus 32. So that gives me 36. So I have the x is equal to 2 plus or minus root 36 over 4. Root 36, so that's the square root of 36. So 6 squared is 36. So my square root is going to be 6. Now, this here means plus or minus. So I've got two possibilities. Either it's plus, so I do 2 plus 6, or it's minus, and I do 2 minus 6. So if I do 2 plus 6, that's going to give me 8. If I divide that by 4, I'm going to get 2. That's the first solution. Then if I do 2 minus 6, that gives me minus 4. Minus 4 over 4 is going to be minus 1. And that is my two solutions. So this is a hopefully clear worked example of how to solve a quadratic equation. It's a good idea to practice this a few times with this worked example in front of you, and it will take a while to master. But if you can do this, it means you can solve any quadratic equation because it works for all of them. So I hope this video was helpful to you and will help you pass the test. I wish you the best of luck in your test, and thank you very much for watching. If it was helpful, please like and subscribe.